Chapter 6, Section 4, Properties of Rhombuses, Rectangles, and Squares. Today we're going to define and classify special types of parallelograms and use the properties of diagonals of rhombuses and rectangles. So it's going to be a lot of rehashing of what we've done before, so we should be able to get through this fairly quick. Key concepts. A rhombus is a parallelogram with four congruent sides. The opposite sides obviously of a parallelogram are congruent, but all four sides are congruent. A rectangle is a parallelogram with four right angles. A square is basically a rhombus and rectangle put together. Is a parallelogram with four congruent sides and four right angles. So we got rhombus, four congruent sides, rectangle, four right angles, and a square with four congruent sides and four right angles. So the Venn diagram over here at the right shows the relationship amongst these special parallelograms. Alright, rhombuses represented in red to the right and rectangles in orange to the right and rhombuses to the left, and squares you notice in the middle. Squares are both rhombuses and rectangles. So looking at the first problem here, in parallelogram, so we know it's a parallelogram, A, B, C, D. If you're like me, you probably really couldn't see it. A, B, let's change our color, see if that helps. A, B, C, D. Is it a rectangle, a rhombus, or a square? Okay, well, as you can read along in the example, we know opposite sides of parallelograms, or opposite angles, should be congruent. So if angle B is 90 degrees, angle D must be 90 degrees. If angle B is 90 degrees, its supplementary, or its a consecutive angle, must make it supplementary. So if B is 90, A is 90, and if B is 90, C must be 90. So we know in parallelogram ABCD, all four angles are right angles. Now, looking at the diagram by inspection, we cannot tell anything about the lengths of the sides, so here's what we do know. The best we can tell is it's a rectangle. Alright, moving on. The next question asks us, is parallelogram EFGHE, is it a rhombus, a rectangle, or a square? Well, what do we know about parallelograms? We know opposite sides must be congruent, and that's the only thing we can really tell by inspection of this diagram. So we know all four sides are congruent. Since we cannot tell what the angle of H, E, or F may be, or G for that matter, the only thing we know for certain is that parallelogram is a rhombus. Again, rhombuses, four congruent sides. Rectangle, four right angles. A square is both a rectangle and a rhombus. Theorem 613 says this: if a parallelogram is a rhombus, then its diagonals are perpendicular. So if we know all four sides are congruent, then we know the diagonals will be perpendicular. That is for any rhombus. Theorem 614 says this: if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So we know angle 1 must be congruent to angle 2 because it's bisecting these things. Angle 3 must be congruent to angle 4. Angle 5 to angle 6. And angle 7 to angle 8. Problem 2, finding the angle measures. What are the measures of the numbered angles in the rhombus of ABCD? So we know it's a rhombus. So we know AB, BC, CD, and AD are congruent. We also know, the diagonals of a rhombus are perpendicular. So we see angle 1. So we know angle 1 right now. The measure of angle 1 must be 90. And we also know alternate interior angle theorem. So if we look and we know A and B must be parallel to CD, that means this line right here, BD, that I'm drawing, is the transversal. So angle 2 must be congruent based on alternate interior angles. So angle 2 must be 58 degrees. If we know angle 2 is 58 degrees, and we remember about rhombuses is that the diagonals are also angle bisectors, we know angle 2 must equal angle 3, so angle 3 must be 58 as well. Okay, so we've got measure of angle 1 figured out to be 90, 2 and 3 are both 58, so now we've got to figure out angle 4. Well, we can remember a few things, so let's just draw our triangle of the bottom part again. We know angle 1 was 90 degrees. We know angle 3 is 58. So, angle 4 we got to figure out. That's the question mark. So we know the measure of angle 1 plus the measure of angle 3 plus the measure of angle 4 will equal 180. Well, that would be 90 plus 58 plus the measure of angle 4 is 180. So 148 plus the measure of angle 4 equals 180. So subtract 48 on each side. The measure of angle 4 must be 32. What are the measures of the numbered angles in this rhombus? Again, we know it's a rhombus, so we can make some conclusions. Okay, the only thing we know right now is angle Q. Well, let's just look at this for a second. We know right now that angle and that angle are congruent, and that angle and that angle are also congruent to each other. We know this because let's just draw our triangle P, Q, R. Well, if we know angle Q is 104, we know PQ and QR are congruent, we know angle 1, we'll just put X for now. We know both those angles, opposite angles, must be congruent. So we can say 2x plus 104 equals 180. We know that because the sum of the three angles, which would be 104, x, and x, has to equal 180. So we subtract 104 on each side, so 2x equals, I don't know why I put 108 there, 180, 204, so 2x equals 76. Divide each side by 2, so x equals 38. So the measure of angle 1 is 38, which would be the measure of angle 2, which would be the measure of angle 3, which would be the measure of angle 4. They're all 38 degrees. Theorem 615. If a parallelogram is a rectangle, then its diagonals are congruent. And we also know, because of parallelograms, that the diagonals are also bisectors. We know, in this example, those must be congruent. So let's look. in rectangle RSBF, SF, the length of SF equals 2x plus 15. I'll highlight that in yellow so I don't have to write it. And RB is 5x minus 12. Well, it told us it was a rectangle. So we know everything's right angles. So the diagonals of a rectangle are congruent. So all we have to do is say SF equals RB. So FS is 2x plus 15. RB was 5x minus 12. Okay, I like to get the x's to the same side, and I like to keep them positive if I can. So we're going to subtract 2x to each side, and we're going to get 15 equals 5x minus 2x is 3x minus 12. Well, we got to get x by itself, so we're going to add 12 to each side. So we're going to get 3x is equal to 27. Equals 3x. Divide each side by 3, so x equals 9. Well, that's not what the question asked. The question asked, what is the length? What is the length? Alright, so we know the length of the diagonal is 2x plus 15. That equals the length. We also know we got x is equal to 9. So we're going to plug that in for x. So we're going to get 2 times 9 plus 15 equals SF, which would be 18 plus 15 equals SF. So 18 plus 15, so 33 equals SF. So I shrunk it down a little bit, so you can see the answer would be D. So again, we know the diagonals of a rectangle are congruent. Alright, in this figure it is a rectangle. So we know the diagonals are congruent. We know all the corners are right angles. We know a lot of stuff. If Ln, let's highlight Ln, is 4x minus 17, that'd be Ln. And MO is 2x plus 12. What are the lengths of the diagonals? Well, again, the diagonals are congruent, so we can say Ln congruent to MO. We can just plug in 4x minus 17 equals 2x plus 13. Again, I'm going to subtract 2x on each side. We're going to get 2x minus 17 equals 13. We're going to add 17 to each side. So we're going to get 2x by itself on the left hand side. 2x equals 30. 13 plus 17 is 30. So divide each side by 2. X equals 15. Well, that's not what it asked. It asked for the segments. Well, we found out x equals 15. Here's an equation for the length of the rectangles, or sorry, the diagonals. So we can just plug in our x values. So we can rewrite that as 2. Instead of x, we'll plug in the 15 plus 13. So 2 times 15, that'd be 30 plus 13. And 30 plus 13 would be 43. So the length of the diagonals, so MO equal to LN, which is equal to 43. The next question is, what type of triangle is PMN? Okay, well, let's think about this. What do we know about parallelograms? We know that the diagonals are bisected. Well, we also know in a rectangle the diagonals are congruent, so that means the bisected parts would both be congruent, so that would become an isosceles triangle. isosceles triangle. Before we let you go and get you on your homework, let's make sure we know how to do these things. Each of these examples, a parallelogram is a rhombus, a rectangle, or a square. We have to explain. Number one, we know for a fact all parallelograms, opposite sides, must be congruent. So number one, we know all four sides are congruent. That's going to make it either a rhombus or a square. We know opposite angles must be congruent. So if the upper right is a right angle, the lower left is a right angle. We also know consecutive sides must be supplementary. So if one angle is 90, the consecutive side has to be 90. So we have four right angles and four consecutive sides. So number one we can define as a square. Number two, it has four consecutive sides, or four congruent sides, and it has one angle of 130. Well, we know if it has four congruent sides, it is either a rhombus or a square, but a square has to have all right angles. So number two is a rhombus. Number three, what are the measures of the numbered angles in the rhombus? We know right now that a rhombus, when they intersect, they make right angles with their diagonals. So we know angle 2 must be 90 degrees. So angle 2 must be 90 degrees. We also know rhombuses make angle bisectors. So angle 3 must be equal to 50. So we know angle 2 is 90. We know angle 3 must be 50 because on rhombuses the diagonals not only create a right angle, they also are angle bisectors. So now we have the smaller triangle. Let's draw that up so we can just see it. We know that's a right angle. We know the angle on the right hand side is 50 degrees. So we need to find out what angle 1 is. So angle 1 plus 50 degrees plus 90 degrees must equal 180. So angle 1 plus 140 equals 180. So angle 1 must equal 40. So our answers are angle 1 equals 40 degrees, angle 2 is 90 degrees, angle 3 is 50 degrees. So now you can get started on your homework, page 400, 7 through 35, 37, and 39.